So as been said, Shadi Razak, I'm the Chief Technology Officer and one of the co-founders of ANGOKA. I'll be talking about securing the Internet of Drones, and I'll explain different things and a new approach and hear your thoughts about that approach more than anything else. So I tried to keep it a bit interactive if I can in those 20 minutes. But shamefully enough, I have to do a first 2-minute sales pitch and into the process as well. So just to give you background, we are an IoT security startup based in Belfast. We started in 2019. We work very closely with the National Cybersecurity Centre in the UK. All of our technology is actually supervised by the team there. We have offices in Belfast, London, and Den Haag. And we collaborate with a lot of universities on our technology. We purely focus on smart cities and smart mobility, where you have cyber-physical system, which is critical. And you've heard Peter Davis about the examples that he gave and the system of systems. So we focus on air mobility and securing command and control communication between the drones and the operators, between the drones and the unified traffic management systems, but also we apply it to infrastructure. And we have quite a legacy infrastructure for transport across the world. We are engaged with the government of Flanders as well as England Highways of upgrading the security of our infrastructure and ensure that we cannot have a disaster based on an attack that's targeting that infrastructure. Our heritage we are a spin-out from an Innovate UK project for CCAV, connected autonomous vehicles. So a lot of our work focus on connected autonomous vehicles and purely the teleoperation side of it for the vehicle and the command and control between the driver and the vehicles. And we've done multiple trials as well and secured teleoperating passenger pods in Cambridge, in London, and in Oxford, while the teleoperation was up in the north into the process. And the latest is securing hum, health and usage monitoring for devices. An example I've put there, the battery in the vehicle, but that goes across infrastructure as well. That is the sales pitch, and now I'll jump into the talk. So Internet of Things, it's quite an interesting topic. We throw it on everything, and in reality it's quite a wide title that we use because you can apply it in different industries. And if you look, for example, into vehicles, IoT can be the sensors on a battery communicating to the cloud or to the edge, or even communicating to other vehicles through the interaction. So it's almost vehicle to X type of communication. In factories, you're talking about Industry 4.0 and the automation of the factories and supply chain that linked to that one. If you look on the smart grid, on the electricity, smart meters nowadays that we have, but there's also a movement further. So we're working also with a company that make your boiler at home as a data center. Netflix and Sony are interested to work with them. So that means you not just generate heating for you, you get paid by Netflix and Sony for processing data into your boiler. So that opens a huge element on energy distribution systems and smart homes from appliances. And moreover, and the last one is the Internet of Drones, which is a term that it's really important to address because drones are becoming more of a reality. And it's not just a drone. There's a whole system of systems that is connected to the drones. A lot of people focus on securing the drone itself and the communication from the drone. But in reality, you have a wider system of systems that you need to look at. And that's what I'm going to try to talk about today. And just to clarify, going back to it, a lot of the times when I talk about drones, people think about it, yeah, it's quite only advanced into defense or into crime fighting, which is more on, the hunter or the killer UAVs, similar to the stuff that we have seen in Ukraine on that one. Or, for example, to use it like Eagle Eye, the movie that we have seen where they are using drones to spy on people in houses and targets into it. But that is not the reality. There's a huge applications, and those applications are already exist, from medical delivery, search and rescue, border patrolling, or commercial as well. And in the UK, has been dedicated by the government a 75 million pod on these projects. And this is the landscape. A lot of these projects that are being run at the moment under the Future of Flight from Innovate UK, 1 and 2 and 3, are for different areas. So some of them on medical delivery, the first corridor between London and the north to deliver medical aid between hospitals, organs, blood, medicine that is needed. Then you have, for example, others that there are the corridors to deliver products between the islands that we have, Isle of Wight and Jersey and the others, and connect them directly with the port on England, and so forth that you go through. And as you can see, we are involved in few of them in the latest, and mainly we are focusing on the security. Now, from this type of projects and involvement that we have, comes the system architect. And this is a typical system architect that we have seen. And as you can see, it's more complicated than just a drone and a person who's flying the drone. There's an operator for the drone. That operator needs to submit the plan that they want their drone to fly through to what we call a unmanned traffic management system. That unmanned traffic management system will actually communicate to the monitoring airspace in order to get information, as well as other data service providers, such as the weather, for example, airports, police, defense, in order to understand, is this plan that this operator providing, such as Amazon, DPN, or an NHS, in order for them to fly a drone from location 1 to 2 is possible and allowed. Now, of course, then the UTM will give the good to go or not, or you need to change that information, and that will goes directly to the ground control station, which is mainly what control the drones through the process. Now, currently we have an issue within the drone situation is beyond line of visual of sight has not been authorized yet. For a very simple reason is because we do not have a legal framework to support it. And we do not have the infrastructure as well to support it, as 5G is not stable enough, public 5G is not stable enough to support it. So that means those ground control stations, they need to have a line of visual of sight for it. Some of the projects that you have seen that we are involved in, we're trying to push that envelope a little bit further. And that's where you have entities like the civil aviation authorities are actually engaged into these projects in order to see what is the framework that they need to build. Because here you're talking about if one of these drones is flying, let's say, over part of the city, and something happened to it, the battery ran out, it needs to land. It needs to communicate with the area around it in order to land and get a safe landing. How it's going to communicate through that. And this is actually a big problem, because then you will find drones just falling off the sky in your back garden. And that is not the thing that we need. And also you need to regulate it. A lot of people think that, oh, we can use drone to deliver Amazon stuff. Not true, because otherwise you won't see the sun. You will see only drones flying all over the place. So there's a more critical system that you need to look at and address, and different type of communication from 5G to Wi-Fi to Ethernet. Yet we are still seeing we're using a lot of unfit technology that is used. An example, securing the communication between the UTM and the drones or the operators is still using the typical authentication process that we use on the internet. An example, a lot of the UTM, they use OAuth as a service. But you're talking about a service that will take a couple of seconds to establish that authentication, while the drones in those 2 seconds will have flew bypass the points that it have. So that is a big problem for us that we are having into security. A lot of the approaches that we are bringing are not fit for purpose. Plus, we have the lack of mature standards. MAVLink is a very famous communication standard built for the drone industry. Guess what? It doesn't have a security session. There's no authentication, there's no encryption. The latest update that they have produced of it, it's have 2 paragraphs that any communication need to be authenticated, and the operator can decide on the authentication mechanism. That is the challenge that we have. And then the absence of a clear governance or legislation around it, as I said about the BV loss. And that's where it's become quite a problem, because you're using a lot of legacy technologies to secure unlegacy systems. And that is a big gap. And what we have done over the past 3 years, we've done an extensive analysis, and we are launching on the 9th of November a report which represents the state of the threat landscape on drone systems in Europe. On that one, we are hosting an event in Belfast for that one as well. But one of the main categories of these threats that we have seen regularly hitting into the drone implementation is reporting falsified data. So in other words, the drone is giving you wrong location and wrong status data of it. So when you are flying your drone, it will say, I'm on this path, but in reality, it's totally on a different path. Deny access to real-time data. A lot of these drones, especially in the BV loss, beyond line of visual sight, so the operator cannot see it on their eyes, they are seeing it on the screens. If you deny access to cell towers locations, GPS locations, or video stream, they cannot operate it anymore because you cannot see where's that drone is flying. Impersonation of operators or unmanned air systems. And this is the easiest one. This is man-on-the-middle attack. You see it, you jump, you impersonate it, because we are using the same typical OAuth problem. The token got compromised quite easily into that. These attacks has been documented over and over again. And we have done a number of these attacks in real life on some of the projects that I have listed. We've recorded. If anyone is interested, more than happy to share those recordings with. The last one is the tamper with the telemetry data. And this is quite crucial for drone manufacturers, because a lot of that telemetry data tell them about how long are these battery lasting. And some of the drones that you can use for those deliveries, they fly on a certain height. The higher that they go, the battery is consumed quicker because of the air pressure and the cold. So it's quite important for them to get that telemetry data. This is just an example of some of these attacks that we have found, and the different assets from ground control stations, unified air systems, to the communication channel, and what type of communication that you're looking at into the process. But also, there's a problem on this, which I'm happy that the second talk will touch on it, is there's no fit for purpose, a threat model, or a risk assessment framework for Internet of Drones, for cyber physical system. We are still using the typical systems that we are using on the Internet, which is different because you're talking here about people's life. So that changed massively the level. So what we have found from a mitigation, there's an important part. We have found that increasing the separation between the devices and the subsystems help us to create more resilience and make the attack surface more reduced for the attacker, and increase the sophistication of the skills that the attacker needs, which means you are reducing the number of the attackers or the type of the attackers that they will do it. So it will be either organized crime or state actors at that time. So you are cutting a good percentage of type of attackers by just creating that separation between those different systems. But also by increasing the transparency into the system and the trust into those systems, that's where you start increasing the resilience. of the network. And you start building self-healing systems, which is the interesting part into that process. And this is the approach that we have suggested, is what we call creating a device private network, DPNs, not VPNs, DPNs, okay? VPN exists on the higher level, on the communication, that routes it through a third party, that's normal. But a VPN is more of a mesh peer-to-peer type of communication into a system that start from the silicon of the devices directly. So what is a DPN and why we have created that, why we came with that idea? We need to build a trust relationship between those devices. But most of the time we build that trust based on the configuration from the main system and we go ahead with it. What we have done here is we created the trust between the identity of each device, and the identity is not given, the identity is generated by the device. And that's the difference. So you don't take a token from OAuth and you put it into the device and then you use that token. The device generates its own tokens through the process, which allow you then to build trust boundaries between the different systems. So between the drones and the ground control station, that's trust boundary. Between the ground control station and the UTM, it's a different trust boundary. And between the UTM and the public authority, it's a different trust boundary. And within these systems, you run a regular authentication because you have the identities are dynamically and on demand generated. And for each network, you have a different identity for that network on a regular basis, depending on the sessions. So what you achieve through that is building trust over untrusted networks. You don't care anymore about whether if it was 5G on BT or EE, or if it was Wi-Fi, or if it was Bluetooth, and who's the provider, and do they have firewalls on the networks or not, and do I need to authenticate it or not? What you need is just to authenticate between the two systems and build that structure, right, through the process. What I'm talking about is not something out from this world. It's actually taking the zero trust principles and applying it into the Internet of Drones, but with a bit of a twist. And the idea is to generate that immutable digital identity, which is, as I said, it's based on the device's characteristics, hardware, software, and the system that they are part of. And they are generated on demand on the device, and then they will do a mutual authentication between the devices, and then they will start micro-segmenting the different infrastructure and the application according to that identity and build those trust boundaries. Similar to what we have heard earlier today about Cherry and building those containers and the different type of. But now we are taking it a little bit higher on that process. And that will allow us to generate those DPNs. But as you see, it's all based from here. It starts from the identity and the framework that is built by the identity at the same time, which allow you then to self-heal your system. So if an incident happened, and this is the reality, we compare between what we are doing, or that principle, and common systems that exist. If an attack happened, we spot it in milliseconds. The other system will take till the network assess it, till you do the analysis, till you identify it. You're talking between 5 minutes on some systems till an hour. And that is the difference. So the networks can self-heal itself quickly, or at least quarantine the targets. On that, I'll stop. I would love to hear later on your thoughts, your reflection. Does that sound reasonable? Not? Is there any other alternative for it? Or is it something you are working on? Then I'm more than happy to have a chat and try to collaborate on it further. I think that's from me.
Thank you very much.
And just before I go, sorry, I need to thank my team as well because they participate in this study. And without them, we wouldn't have done that study at all as well. Thank you.